Welcome to the first lecture of Edexcel ICT A-level. So we are starting with the first topic, which is hardware and software. And as you guys know, Edexcel is split. Edexcel AS and A-level, AL or AS and A2 is split into two papers, two components, as well as ICT is divided into 4 units. So unit 1 and unit 2, and we are starting from the first unit, the unit 1, and this is the first topic of unit 1, which is hardware. Okay, so we'll be discussing about the primary points about hardware, and we'll talk about the crucial components of a computer, why we need these components, and we will discuss how these components interact with us in our day-to-day life. Okay, so let's jump in and see how this module is built. Super. So, table of content. So, what are the points we need to learn here? So, primarily, we'll be discussing about the features and functions of contemporary digital devices. Okay, so contemporary digital devices, that means the type of digital devices we have in type of digital devices we use on day-to-day basis, and like type of devices like user interface, connectivity, cable types, and media support, and so on and so forth. So all the primary points. Okay, and then we'll be discussing about the primary computers and peripherals. Okay, so what are the primary devices we use, and the computer and peripherals, and at the same time we'll be talking about understanding the technologies. So what are the technologies which is behind these devices, and what powers these technologies? Okay, so let's jump in and see how it works. Okay, so starting forward with hardware. What is hardware? Okay, so hardware, think of your computer. Okay, now think of your computer like your body. So what are the primary components you need to interact with someone, or basically to live your life, right? So what are the components you need? Let's think about this as a computer. So you need to have your eyes, you need to see, you need to talk, your voice or your mouth, you need to listen or you need to hear. So you need your ears, as well as when somebody tells you something, or when something happens, or in order to move your hands and walk and do whatever the activities you want to do, you need a processing unit, right? So that processing unit is your brain, correct? Yeah, so now these points, these primary devices, right? So now apply the same concept into a computer. What do you get? You can replace your eyes with cameras. As you might have seen, all these new robots coming out. Tesla has a robot, and all these companies are coming up with realistic robots, right? So what are the primary components these robots have? They have cameras to see, they have microphones to hear, they have actuators and motors to move their limbs and arms and feet and everything. Plus, the core component is they have a CPU, they have a brain where, using the CPU, the central processing unit, you can process the data which comes in, and it will help you basically work and interact with people. Okay, so think of it as a body, think of the PC as a body, and as you can see, these are the points which works, right? So in a computer, we need to provide power in order for the computer to work. But when it comes to our body, we eat and our bodies metabolizes the food and gives us energy, right? But then again, it's all part of the ecosystem, right? So upgrading your hardware. Now let's say when you go to the gym and you must pump some weight, right? When you do that, and plus when you add some protein, so you need to, if you eat more or if you drink more, drink protein like drink milk and all, what happens is it will strengthen your muscles. You will be able to build your muscles and it will size up, right? Upgrading hardware on your PC is something similar. So what do you need to do in order for you to upgrade your hardware in your PC? You will have to upgrade the components, right? So example is, if you want to make the computer faster, you will have to increase or change the CPU. And at the same time, if we compare this with your body, same neither. So if you study and if you feed your body and if you feed your brain capacity goes up, right? When it goes up, that means it can process faster, right? So I hope my point is clear. So likewise, software and hardware, hardware and our bodies work together, right? But as based on all this hardware, but there's another problem. Now, okay, think of this as a young, a small infant, a baby, a newborn baby. Does the baby have any memories or any inbuilt options in it? No, right? So now software is also something similar to that. So what we do is we learn. When we were babies, every day we learn something new, which is being stored in our memory, our CPU and our brain, and then that allows us to process the data and use it in a particular way so that we know how to run the actions, right? Software is also something similar to that. But let's get to software because we have a dedicated topic for software. So let's finish up hardware. Let's dive in and see what wonders awaits us when it comes to the hardware. So primarily, features and functions. What do we have? So what are the features and functions? Now, hardware, when it comes to computer hardware, forget about the human body and the babies and the brain and everything. Now we are talking about hardware. Okay, so hardware features including physical components of a computer like the CPU, basically the brain, and the RAM, the memory, the motherboard. The motherboard is the backbone. Now, all your components are actually fixed into the motherboard, right? And then you have the storage, which is going to be the hard drive, as well as you have peripherals. You have keyboards, you have mice, right? All these are support peripherals, which will allow you to do what? Yes, allow you to interact and work with the computer, right? Perfect. So just think, without a keyboard or a mouse, how can you perform some sort of an action? You can't give a command. No? You can't just say, hey, do this. Yeah, you can, but then again, for that, what do we need? In order to give a voice command, we need to have a microphone, right? Yes, exactly. So in order to provide a voice command, we need to have a microphone. Likewise, these peripherals are really important. Okay, so depending on the function, the type of the hardware generally depends, and based on this, it will be basically storing visuals, connecting to different networks, and all sorts of different features are actually provided using different types of hardware. Then portability. Now, talking about portability, let's go back, let's say not that far, Like if you go into, if you look at somewhat around late 1990s, while, so yeah, we had computers, but technically the computers were big and chunky. So we didn't have this type of small devices like a nice small mobile phones and all. So those days everything was huge. Huge means huge. The first laptop was actually not technically a laptop because it was like this size, this huge, and and there was a massive thickness in it. But that was evolution. So people build stuff. Now it has evolved into a level where we have thin machines and the portability is really improved. So yeah, so when it comes to the portability and the details, so you can see now when it comes to the term of portability, it has couple of let's say couple of definitions. Now for you and me, portability will be having a small device or a device which is easier to take and carry and go to some place, right? That is portability. But then again, it might differ depending on the type of the hardware. Example is okay. A good example, tracking hardware. So tracking, in the sense, those days when you want to map a specific location, people had to literally hire an helicopter. Okay, so you go to the whatever the air force or whatever the company which hires helicopters, and you have to get that helicopter, get on board, get those massive cameras, huge cameras where it has these sensors on it, and you have to fix it into the helicopter, and after fixing it you have to spend a massive lot of money on fuel and everything, and you have to fly over that particular place to map that location, right? Now we have these DJI drones. We have these drones known as agro drones, agricultural drones, where it's small unit, it's like this size, where you can easily charge it, put the battery pack, you connect it to your phone or your laptop, and you just send it. And the best fun part is, in that drone itself, you have a method of selecting a specific area in a map, and when you execute, it literally goes through that particular map. We call it a geofence. We call it, in a way, we call it geofencing, where you create a fence and you ask the drone to travel in that particular path. So all you need to do is, you get the map, you draw the area you want to cover, and you run the code and you run it, and then this guy takes off. He goes and maps the entire land and comes back. And there are something which I saw recently on YouTube, where you have this automated charging stations also. So let's say if you are mapping a huge area, like let's say couple of square kilometers, then the battery won't last that long, no? So you have these automated charging pods where you can place it at a location, and when you ask the drone to map, it goes to whatever the location, maps it up, and when the battery percentage hits a certain threshold, a low threshold, it comes back to the base station, charges up, and goes back out. Okay, so now that is portability. Now earlier days we had to use for helicopters. Now we have small drones where you can get it done. Okay, so the portability definition varies from point to point. Okay, I want you guys to write this down, because this is a point which is very important. And when it comes to your exams, you get MCQ questions asking what is portability. Okay, so please write this down. Portability refers to how easily hardware can be moved. So as an example, laptops and tablets are designed for portability, laptops and tablets, while desktops are meant to stay in one place. Okay, so guys, remember, in Edexcel A levels. Now you guys have gone through IGCSE, or you might have got into A levels by after uh, doing your local O levels. So it's perfectly fine, but you just need to keep in mind when you are writing answers in Edexcel, you need to make sure you follow two points. You need to, so if you get a small answer, sorry, if you get a request to write a small answer, then you must write it in a way where the keywords, the key topics must be captured. Example is, if somebody asks you what is portability, or if you get a question what is portability, then the answer is quite straightforward. Portability refers, or portability is how easy hardware can be moved. Simple. Then, so that's portability, no? Portability when it comes to hardware. But now after that, you have to justify what you say. Okay? Now in this justification, you can say laptops and tablets are designed for portability, while desktops are meant to stay in one place. Got the idea? So that is how you write the answer. So I want you guys to write this down and keep this noted. Okay? And at the same time, if you can draw something right next to what you wrote down, just draw a small laptop and a desktop PC, small box with a screen and a laptop, so that when we go through the revisions and when we are working on creating our short notes, it will be quite easy for you to get this thing done. And also, guys, before jumping into this, I need to tell you one more thing. Now, the way I teach, I always focus on the keywords and the topics. Okay, so we do not write huge essays on ICT. That is not the way you should learn ICT, because ICT is all about learning the keywords and knowing the background of that particular thing. So there is no point of writing huge essays and trying to memorize everything. But what you should do is learn the keywords and assign a specific point to that keyword so that you can track it back. Example is the one I just told you for the portability. So portability is how easily hardware can be moved. Okay. Now, in order to understand it, map a keyword. So the keyword is laptops and tablets are designed for portability. So when you say laptop or tablet, we all know that laptop and tablet, we use it on the go. So the reason you buy or the reason you purchase a laptop is because of 100% mobility, right? That because you want to take it and go to some place. But at the same time, you buy a desktop PC because you want to keep it at one place and work on it. Super. I hope you got the answer correct. You got the idea. Now, performance is again the next most important thing when it comes to hardware, because why did the world evolve so fast into creating more and more much powerful CPUs and processors? The reason is performance. Okay, so going back, long time back, even like not like long time, like about 50 years ago, 40 to 50 years ago, not 50, no, long time ago. Like let's go back to 1940s. Okay, so almost 70, yeah, close to 70, 80 years ago, we had these communication devices, Morse code, and during the Second World War, Hitler came up with this concept where he had a very tough encryption method, and in order for them to crack this encryption, there was a machine which was created called the Enigma machine. If you guys want to check more about this, do a search and check this online. So the problem was those days, these transistors were not, we had transistors, but it was huge. And the number of transistors which you can connect in order to create a circuit was actually very few. Okay, so the first computer, ENIAC. So when they say that back then, when they powered up the computer, the entire lights or the entire power grid of that entire city has gone down. Okay, so that means that computer, it was more than, it was huge. It was like a big building, that entire machine. So that took more power than the city. Okay, so that was all because people were trying to push towards getting high performance. Okay, so when we wanted to get something done, we want it to be done, wanted to get it done fast, right? Example is, now you guys, when you browse the internet, and if you go on YouTube, and when you click on a video, you want it to be loaded like this, right? If something happens, if it starts to, if it keeps on loading, then there's a high chance you might either won't watch it, or there's a high chance you might switch it off or go to something else, right? So we are all in a stage where we all look for performance, right? So in order to cater that requirement, hardware improvements has to be done in an exponential speed, right? So now you guys have an idea about what is performance, right? Now, how can you measure performance? I mean, how can you put a number to the performance? That's the factor where so those are the factors, like the processor speed will help you to understand. So now, a CPU, when it comes to a CPU, there is a certain speed related to it, right? So the CPU must work in a way, or must process in a way, so that it will go through the processing and it will give out the result. Example is, let's say you want to do some sort of a calculation with couple of numbers, and when you want to run this, immediately the CPU will start firing, and the CPU will start processing this data and will try to give you the result, right? That's how it's going to work out. So now this particular speed, the processor which is going to process this, that speed, that is where we will be using, or that is what we are going to use as a performance vector. So to calculate what the performance is. Okay, so we do have this high performance hardware as well. So now when it comes to hardware, we do have a couple of different types of options. So let's say you're building an application or some sort of a service or a system where that would cater to an audience of users who will be using this for critical applications. Example, what I meant by critically is, think of a way where, okay, just think a ambulance system, ambulance tracking system, or an ambulance request system. So if you are in a danger, or if you are in a, let's say, some sort of a accident or someplace, when you request for an ambulance, that ambulance must be immediate, right? Immediately it should be there, not must, it should be there, right? So when you request it, immediately it should send the message, and the people who are there should immediately see it, and you should immediately get medical attention, right? Otherwise, we never know what might happen. So those type of tasks or processes are extremely highly critical. Plus, Sometimes they might be highly demanding as well. Example, when I say demanding, I mean process wise demanding. In the sense, now let's say, um, your let's take the same example. If we take this ambulance, let's say you create a method where you can where the ambulance will take in some data and try to track your location to find out where you called from exactly, right? So if we have that type of a feature, then that means immediately when you got the call or when that system got the request, the system should process and find out where you took the call from, right? So it's very critical and it is process intensive because it will have to connect with multiple servers, find out from where you dialed, and all those information has to be captured at a certain point. So that is what we call as crucial and demanding. At the same time, so what I gave you guys was a bit of a high-end critical scenario, but here we can also learn about gaming, video editing, and running complex simulations. Now, if you guys have seen the newly released, I can't remember the exact name of that. NVIDIA released I can't remember. So NVIDIA released a new CPU called I think Jetson Tho. Yeah, I think so. Yeah, Jetson Tho. So that's a CPU which is built by the company NVIDIA, one of the largest and the greatest GPU companies. See, where they make graphic cards. So this particular processor was actually designed from ground up to be set as CPUs for robots. Okay, so that means like these are like specifically created in a way that they can run simulations. So when I say a simulation, take it. It's a big word. Okay, so simulation means now in the new NVIDIA system, you have this method where you can actually train a robot or an android using a specific simulated world. Okay, example is if you can remember, if you go back about few years ago, not few years, like couple of years ago, we had this Boston Dynamics robotics company. So what they do is, I think you all might have seen those videos. They hit the robots, they kick the robots, and they basically try to move them away from the road and all. So they just fall down and they just stand up back again, and they learn. Right? So that is part of training a robot. Okay, so now when it comes to training, there are two different methods of doing that. One is by actually physically giving it a punch and letting the computer learn on its own. That was how, until NVIDIA released this new thing, that was how we trained robots. But now with the new Jetson Tho CPU, plus with the NVIDIA this simulation, now we don't even need to make the robot. I mean, like to manufacture a robot in order to train it. You can actually create the robot in their virtual world, and then you can run the simulations, which in return the robot's code will actually learn how it works. Example is, let's say, basic example. Let's say you want a robot to sweep your house. Okay, you want a robot to know where are the corners, where are the doors, where's the chairs and all this stuff are, sorry, the location of all this stuff. And you, let's say you want a robot to specifically navigate through this house and sweep the place. Earlier days, before this, before the simulation and all these AI technologies, what you will have to do is you'll have to first map the location, like as I just told you guys a few minutes ago about geo mapping, and then you have to load that particular mapped location into a robot, and you let the robot walk around the place, hit itself, fall down, and all this stuff, and it learns how it works. Then after that, you can give him a broom and he will sweep the place. But then again, still, if you change something, if you just take one chair from one location and keep it to another, or move it to another place, then it's going to be a problem, because the initial training was done with the robot saying the chair is here, but now the chair has moved here. Then obviously he's again going to go and hit that chair and fall down. But with the new complex simulation system, that simulation can be done in a virtual world. You can take the chair and move the chair, and you can let the robot learn. So it learns how to navigate, and just like that, it will let you deploy and change. Okay, so I explained a lot about performance, but I hope you guys got an idea about what is performance is and how crucial it is for hardware. Then storage. So storage is again another point where it's important, because whatever said and done, whatever process is done, and whatever the data is processed, we need to have storage. So without storage, we can't do anything, right? So storage means, primarily, write down the definition. So the definition is, storage determines how much data a device can hold. Okay, you can either write this down in a way, storage devices or storage drives has a storage definition which determines how much data that device can hold. Okay, so in this case, we do have different type of storage mechanisms or storage methods, I might say, where primarily the two types are, we have internal storage and external storage. So tell me an example for the external storage. What do you think? You guys know that's the answer. Yeah, pen drives, right? Pen drives and memory chips and all, anything external, hard drives and any other device which is not fixed into the motherboard, right? So the internal storage means it is technically plugged into the motherboard and it is fixed, right? Okay, so this has capacities. So larger the capacity, that means you have the higher storage of files as the capacity exists. So here in this image, what you guys can see is actually a hard drive, a physical disk hard drive. He's actually trying to, he's removing the screws to lift that particular top panel. So when that top panel is lifted up, you can see the disks. We'll go through the disks, we'll go through this part later on, but do some research and find out, you can check what this is. Then the next most important point is a user interface. So this is also one critical point, right? So how can you interact with a system if we do not have a user interface, right? So that should be a clear point. So when you want to interact with the system, there is only couple of ways you can do that. So primarily, either you need to have some sort of a device to interact with it, but at the same time, even if you have a device, there has to be an interaction interface, right? You need to have some sort of an interface to interact with the system. So example is okay, so let's take a basic example, your television or your TV. So if you have a smart TV, then the smart TV will have a menu, right? When you click on the menu, it will take you to the smart TV's menu and it will show you the options. So that is the interface which you use to interact. If you take any type of an operating system, so then that will allow you to that will give you an interface to interact with that as well. But at the same time, okay, so that is the user interface, but it can be something else also. It can be a physical interface also. Okay, now read the explanation. So it says user interface. The user interface is how you interact with the system and how you interact with hardware, right? Plus, it can be a physical interface as well, right? So it can be either a keyboard, a mouse, or a touch screen, right? So it can be either one of these, and plus at the same time, as I just said before, we have the software interfaces. So the software interfaces, they can be multiple things. It can be your operating system, it can be applications, it can be what do you call it, like these pop-up interfaces, and anything which is provided through software will fall under the category as a software interface. So a well-designed interface will make the hardware very intuitive and easy to use. Okay, so this is a problem. Now, if you take back the example which I told you about the televisions, so now the smart televisions are there. It's actually a bit easy to navigate and use these softwares, right? It's just kind of easy. But then again, if you go back, like long time back, where we did not have smart TVs, so even now itself, we still have these LCD panels without a smart interface. No, I have seen some. So most of earlier days, the TVs and all, they did not had this type of a smart panel. So what they actually had was just a list of options where you click on the options and you see the details, and that was it. So in order for you to change the channel, you just go through the options. So it was not that easy. So there has to be a learning curve for using a TV. But nowadays, no. Nowadays, you just turn on the TV, you get a nice big screen greeting you and with all the details. It's quite easy, right? So that is again an evolution of the user interfaces based on hardware. Okay, then next one, connectivity. So connectivity is also one of the primary points when it comes to hardware, because without having the ability to connect, there is no point of having hardware, right? Why do I say this? Why do I say it like that? It's mainly because without having a point to connect means, now let's say hardware needs to have some sort of a connectivity to interact or interface with different peripherals, right? Example is to connect to a network, you need a network card, right? Or nowadays, to use 3G or 4G, you either use a dongle, a 4G dongle, or you connect using what? Yeah, you connect using Wi-Fi. Correct, exactly. So you connect using Wi-Fi. So Wi-Fi, what? Okay, now you just said that you connect using Wi-Fi. So Wi-Fi is also part of the hardware system, right? So now I think still no. Latest motherboards comes with Wi-Fi installed. Not the latest, but the expensive ones has inbuilt Wi-Fi. Otherwise, you won't get Wi-Fi on a typical motherboard unless you buy a laptop or like a pre-built machine. But like if you buy an original, if you try to assemble the machine, you won't get Wi-Fi unless you spend a fortune or unless you buy an expensive motherboard. So there is also an interface that is also part of hardware which allows the motherboard to connect to the internet. So primarily we have some connection types. The main connection type you can say is USB, which is known as Universal Serial Bus, which is the standard universal connectivity protocol for USB hardware. Okay, so using USB serial bus, you have the option of connecting them and getting them active. At the same time, the standard for displays is now known as HDMI. So high definition media interfaces. So HDMI is now common, and most of the laptops, they do have an HDMI port inbuilt, and I think all the motherboards and all the computers which is getting released, they do by default they do have HDMI ports. So that is something which is being used commonly. And then Ethernet. So Ethernet is also a common thing which is being used for wired networks. Plus, as we discussed before, we have Wi-Fi, right? So the point behind hardware is, guys, remember now, whatever the application you build, okay, let's say you're going to build the next best smartphone in the world, okay, but even if you build it, there's a problem, because if that smartphone cannot connect to the internet, or if the connection speed is slow, then do you think people will buy that? Technically no, right? There's a slight problem in it, because people want performance. We want performance. So we want it to be connecting or to be connected to any other device, or whatever the device which we want it to be connected to, as fast as possible. And we want it to interact as fast as possible, so that we will be able to communicate and use the device, right? So that's what most of the companies does also. Look what a market karane. So they do this marketing. They say example is Google and Apple, they both boast about their speed, hardware speed. They say we have the fastest internet in our phone, or one might say one of the fastest phones with the fastest 3G or 4G connections or 5G connections, right? Likewise, they always try to push in forward with the connectivity, so that people can actually use it. The next one is media support. So why do we need media support? When it comes to hardware, it should and it must support a certain set of media types and media files, right? Because by default, so this doesn't say that every hardware device needs to have media support, but media support is actually a part of hardware. So different hardware types have different support for media and devices, right? So example is some hardwares have specific device support and some has multiple different types of device support. Example is if you take a video camera or a DSLR camera, when you take a picture from a camera, that picture is actually saved in a specific format, right? And a camera is actually a piece of hardware which is designed to perform a specific activity or one or two specific activities, right? So, what are they? So, what's the main purpose of a camera? Yeah, to record, okay, and to take pictures, right? Yes, so either you record something using a camera, a video recording, or you take pictures. So back then, like going back about 30 years ago, before these digital cameras were invented, we had reels, like we had huge cameras with two reels where they move it on dollies and they shoot all the stuff and all. So everything was recorded into movie reels, right? Nowadays we do have smartphones and we can just record it to our internal storage. That's a different story. But then again, the support is important, okay? So yes, camera has limited support, but if you take your phone, if you take your mobile phone, that has like unlimited device, unlimited support for different types of data, right? You can take pictures, you can edit pictures, you can edit documents, anything, right? And at the same time, you do have the audio and video inbuilt support as well. Then energy. This is also one more critical component or a critical point which has to be focused when it comes to hardware. Why? That is because primarily the energy usage when something happens, when a system is online and when the system is actively using some energy, there is a problem because energy is not clean, right? For us, even in Sri Lanka and most of the countries, we are still not using renewable energies, right? So there are countries who uses renewable energy, but most of the time we do not tend to use it. So that means if our hardware is using massive lot of power or energy, that is going to lead us into that will take us into two different outcomes. One is we'll get a high electricity bill, plus our carbon footprint will be much high as well, right? Because we will be spending a massive lot of money on trying to bring it back, so to repair the mother earth, right? So all these things are points which is critically which must be critically evaluated. So yeah, hold on. So when the efficiency is less, that means that would primarily lower the electricity bills as well as it will increase the battery life. Okay. Now energy consumption, as I said, it goes both ways. So one way is for the wastage and for the money and all this, the impact on the world. At the same time, other way around, it's about saving energy so that you can run or use your devices much longer. So example is if we take an electric car, so that car battery and the hardware has to be very optimized, right? Has to be 100%, 150, no, not 100%, like 200% optimized. Because why? We want that system to run longer, right? If you take a drone, that drone must be lighter, but it also must run at least for a certain specific time limit, because so that you can get your things done, right? So likewise, the energy consumption is important. I hope you guys got the idea. Next is the expansion capacity. So what do we mean, like, what is expansion? One second. Yeah. So expansion capacity, capacity and capability both. So extension capability is basically the system should be able to have the capacity to expand or extend its hardware restrictions or hardware limitations. Example is, now if we take a typical motherboard or a laptop, there is a certain, that laptop should be able to upgraded, right? Because you should be able to change the CPU, or you should be able to change the RAM. And when we do those things, that means that will allow us to expand the capacity and the capability of the device. Okay, so if your hardware is expansion proof, like if your hardware can be expanded into different using different software, then yes, you can rest assured that it is going to be future proof. Okay, so hardware expansion will automatically extend its life. Okay, so if the hardware is expandable, then obviously you have the option of expanding its life as well, right? You don't have to throw away anything. No? So if something goes wrong in your machine, you should be able to easily fix it by attaching some, let's say, okay, uh, let's say you start by doing something like, if you start to do a video editing program, or let's say you got some video editing work and you want to do that, but let's say your machine is not capable of doing that particular video processing, then if you had the option of expanding your RAM and your CPU might give or take, then you might do that, right? And then that will make sure that rest of the components will stay as it is, and it will help you money wise, as well as it will help you to maintain it, and the other way around, it will make sure that the mother earth will not get any discarded devices. All these things must be taken into consideration when you're creating when you're creating hardware. Then security, the main factor. So security should protect, or the idea behind security is to protect hardware and the data which is inside the hardware from unauthorized access or unauthorized damage. So you guys can actually write down this point. So it says security features, they protect hardware and data from unauthorized damage. Okay, so please go through this, and when you're writing it down, write down these topics, because these are the important keywords which you will be getting in your exams. So these can include physical security, locks, biometrics, authentication, or this can include security or software as well, security like software security and antivirus firewalls, and so on and so forth, right? So there can be multiple different types of security features, and the better the security feature is, or let's say not better, let's say the structured or the as better the security solution is, then we can make sure that the software or the hardware won't get damaged at a certain point. Okay, then we jump into a point where we talk about contemporary digital devices. So, what is contemporary digital devices? Now, this is a point which we will have to clearly go through one by one and see what this is. So, let's jump in. So, have you ever wondered how we went from huge phones to pocket-sized supercomputers? I know you guys. So while the time, so this video is recording, I'm pretty sure you guys might have not seen these old phones where it was actually so bulky, it was not actually portable, and there was a time period. This was, I have never seen this in Sri Lanka though, but there was a time period where cars actually had phones fixed in them. So just do a Google search and see car phones. So back then, car phones was actually a good massive hit, because people actually wanted to have phones inside their cars. So car phones were kind of a big thing. And in the side of a dashboard, there was actually a phone, like a phone receiver. So you can dial and you can take a call. Okay, so that was where we started. And now, see how we have evolved, because now these digital devices, they have evolved into a so complex level, and they have simplified things, right? Now actually a smartphone is a necessity. Those days a smartphone was a luxury, but not even a smartphone. Those days a phone was a kind of like a luxury. But now a smartphone is a necessary item, right? And so they basically let us send texts and messages and so on and so forth. So why are we talking about this particular point is, we need to understand the type of devices we have. Okay, so now let's jump in and try to see what are the type of devices which we use. So primarily computers. Under the category of computers, we do have desktops, right? So the desktops are the common type of computers everybody have used, right? So these desktop computers, what they do is they are powerful, and so tell me, why do we need so what's the primary purpose of a desktop? Yeah, so desktop, yes, you can use it to play games, you can use it for productivity, as well as you can use this, you can use it for multiple different purposes, right? But primarily, when you call a PC a desktop, that means you're referring to a performance powerhouse, right? You're looking for something which has high performance in it. Something similar to like, let's say, if you have a video editing studio, then for the video editing part, you must buy something which has that capability of editing a video, right? So desktop PCs, they usually consist of a tower, and you have the internal components, as well as when you define a desktop PC, usually the keyboard and the mouse and the monitor also must be there, right? Otherwise it will be a laptop, no? Right? But nowadays we do have desktops without with the like everything built in. So it's like the Apple iMac. So you have the screen, and everything is actually baked into the screen. So one device, you still need to use the keyboard and the mouse though. But what this offers is, this offers extremely high performance and expandability, because it has so many ports and all. Now in a laptop, the space you have is very small, right? So the number of items you can put in or push in is like drastically getting down, because when it comes to a laptop, as we discussed before, the main idea is portability. So what we need is, we need to make this as portable as possible. So what do you do in order to make things portable or make it portable? You remove a certain set of components, right? So when you remove the set of components, what you do is, you try to shave off as much as possible so that it will contain only the required points, and there will not be any expansion or expandability, because those points will be removed. So that's the idea behind the desktop and this thing. And then so that's desktops. Now we talk about tablets. So tablets, everybody knows what is a tablet is, right? Yeah, so everyone knows what is a tablet. So the tablet is a portable touchscreen device that combines the features of a smartphone and a laptop. So don't mix this thing up. It's not a desktop PC, it's a laptop. So you have a smartphone hybrid with a laptop, without the screen, without the keyboard, you just have the screen. Okay, but nowadays we get laptops with the touch screens as well. So now the things have changed, right? And for what do you use it? So tablets are mainly typically being used for browsing and watching videos, as well as used for productivity. Like example is like if you want to take it to some place, work on it. Let's say you're traveling and you don't have the capacity to take a laptop and go. So if that's the case, in that case, the option would be to come up with a tablet. And this tablet, since the tablets are lightweight and easy to carry around, it will basically make it an ideal item to travel, right? Okay, and then we have smart TVs. So we already talked about smart TVs. So smart TVs are the opposite of a typical normal TV. And what do they offer? They do give you some good features. Primarily, they give you access to the internet, right? So about 90% of the smart TVs comes inbuilt with the capacity of handling a network. So you can actually plug in a network cable, and then you can access the internet. And most of the new, I think about 90% of all the smart TVs, they do run an operating system. So I recently bought a smart TV, and that smart TV is running on Google TV OS. So when you start the TV, you get the Google logo, and Google TV OS is actually part of Android. So you have a app store where you can just go to the app store and download and install whatever the apps you want in the TV OS. So it's quite interesting, because you have all your favorite apps there, Netflix and movie applications and whatnot. Whatever the application you need, it is there. So it's just a matter of installing. So it's interesting. Plus, on top of everything, these smart TVs comes with a suite of features like voice assistance, allowing users to control the system with voice commands, and all sorts of activities are there by default. So example is this Google TV OS. The microphone comes with the remote comes with a microphone like this one. There's a small microphone on the top, and you can press and hold a button and you can give a command saying I think hey, I'm not sure whether it's hey Google or something. So you can just send a command, and once that command is sent, it's get read into the system, and it will perform the activity. You can literally ask the TV to show you YouTube videos of a celebrity. Just need to tell the name and then that will process. Okay. So those are the interesting stuff when it comes to TVs, so smart TVs. And then game consoles. Okay, how many gamers are here? I hope a couple of gamers are here. Okay. So I'm personally a gamer, so I do have I I have a PlayStation 4 Pro, but wanted to buy the PlayStation 5, but then I went for a Steam Deck. So now I do game on Steam. So yes, so what are these game consoles? A gaming console is basically similar to a PC. Like sometimes they are like much faster than PCs. Huh? So they are similar to a PC but specialized in gaming. So they do have a specific architecture and a system structure where it will basically push the game developers to develop the game according to the hardware. Example is, if you have any gamers here, you guys will know that we get these games called exclusive games. We get like a certain set of games from Microsoft and another set of games from Sony, where they basically lock these games into their platforms. So technically, like Sony has their own development studios and all, so they focus on building games only to run on Sony. So likewise, it's a big market. Huh? It's a massive market, and that's why now we are talking about it as well. So in simple terms, a gaming console is a computer, but specifically specialized and created for gaming, and they are also specifically analyzed and created to be used on televisions. So ideally, you don't plug a game console to a monitor, so that is technically designed to be used on a big 80 big screen. Okay, so just remember the popular names. So obviously you guys should know this: PlayStation, Xbox, Nintendo Switch, and yeah. So and Steam is also there. Steam Deck. So those are the top consoles which is there in the market. Then we jump into a point called single processor and microprocessor computers. Okay, so what is a single processor and microprocessor computer? Okay, yeah. So about microprocessor computers and single board computers. So what are these type of computers? Now, when it comes to, so we talked about desktop machines, we talked about laptops, tablets, and mobile computers and all. But on top of all these type of computers, we do have this other category which is known as microprocessors or single board machines. Okay, so what this does is, now example is let's say we have devices which will require a certain specific computational action. Okay, so a simple example is if you take an air conditioner, or if you take something like a washing machine. Okay, so these devices, they actually require you to perform a specific set of actions, right? Similar to an embedded system, but embedded systems, as we discussed before, those are like strict actions. Do 1, 2, 3, 4, done, right? But then again, now when it comes to an AC, or let's say if you take a fully automatic washing machine or a fridge or anything which has some smart features in it, then they need to process a bulk load of data, right? So when it comes to processing a bulk load of data, you will be required to use a microprocessor, right? So what happens is, okay, so let me explain what is a bulk load of data. So a bulk load of data is basically something which is using multiple sensors to get some data in. Example, okay, let's take an air conditioner, or okay, let's take a washing machine, a fully automatic washing machine. So I'll explain you how it works. So now initially, so I do have a fully automatic washing machine which we bought almost about 10 years ago, and we still use it. It still works. That has a microcontroller, a microprocessor, where it basically analyzes and runs few items. Okay, so what are the tasks for a washing machine? It's quite straightforward. But what it does is, it basically, since it's a fully automatic washing machine, when you put the clothes in, first of all, you don't put the water. So the washing machine first has sensors, and it actually measures the weight of that, whatever the let's say whatever the clothes you have put in. Okay, so it first measures the weight, it weights itself, and then after weighing it, it will basically fill the water according to the weight. Okay, so that reduces the water waste a lot, because ideally, if it is a not normal washing machine, we will obviously fill it to the top, right? We will fill water to the top, and we put all the clothes in, and we try to wash it. But at that time, when it comes to the, comparing that, the fully automatic washing machine automatically weights, check the weight, fills up the water, and then after filling it up, it has automated compartments where it will automatically put the required soap, the required amount of soap, and the required amount of detergent into the water. Okay, and then that way it will make sure that the dresses or whatever the clothes you have put in is properly washed. Okay, so that requires a lot of processing, right? First of all, it has to weigh the clothes, and then it has to check what type of clothes are there, and check the feature of the what type of washing we have selected. Example is, if you want to wash a big cloth like a bed sheet or something like a what do you call this, a rug or a bed sheet, then you have the option to select. So when you select the option, it has a complete process in it, which will basically understand what it is, and it will process and it will run the required hardware to work it out. So these type of microcontrollers, they are often being used for robotics and in projects like drones and self-driving small robots and all. So at most of those locations where we need some sort of an input output device, where it needs to contain some logic and a program code, then that is where you use a microprocessor or a microcomputer. Okay. And then we have wearables. So wearables, I'm also wearing a wearable computer. So this is an Apple Watch where it basically tracks my heart rate and details and the movement and so on and so forth. All those details are actually being tracked. So wearable computers, these were recently introduced. They were there in the market for some time, but it was expensive. And recently only, about 10 years ago, the market got changed and it became cheaper, so people were able to afford it. And these things, they have a massive lot of activities inbuilt. So this Apple Watch has oxygen detection, heart rate, and movement, and there's a lot of different types of small points when it comes to detecting your health and other figures. Okay, so these are devices which you wear in your body, on your body, for a certain, like a long time period, as well as you use them to track your fitness, as well as sometimes you use it to track. Let's say you have this blood sugar monitors, where you can actually wear it on your arm, and then that would automatically check your blood sugar on a timely manner, and if it is required, it will automatically administer a certain dose of whatever the medicine which is required, so that your health will be intact. Okay, so there are different types of wearables. So these all contains a CPU. This has an inbuilt CPU in it, and this particular CPU is powerful, and it has all the features to make sure to keep on track. Okay, and then we have supercomputers. Supercomputers, now it's actually the hype of things, where people always talk about supercomputers as well. So supercomputers are not something which you and me will buy and keep at home, because they are like extremely powerful computers, where they are designed in a way to perform billions and trillions of calculations a second. So supercomputers are not technically being used for day-to-day processing, as you know, and they are like quite expensive, quite innocent, really expensive. And why do we use it? Primarily for research, scientific research, prediction, weather forecasts, and different types of climate modeling, and whatever the task which is required some complex processing, it would be a point of using it will give the option by using a supercomputer. Okay, so supercomputers are obviously, most of the time, they are housed in large data centers, and at the same time they require a massive lot of people to maintain. You can't just host a supercomputer at a certain point and get it up and running. It will not work. You need to have multiple people to manage, and like using this controlling a supercomputer is actually a big task. Okay, and then we jump into peripherals. So peripheral devices. Every PC needs to have a peripheral device, right? So we need to have input-output devices. So we know about keyboards. So we'll start from keyboards. Simple. Keyboards input device which will allow you to enter text, numbers and any command into a computer with the standard structure. So they have a certain set of keys or a certain set of key layouts which will basically allow you to come up with and set the structure in, right? So these keyboards can be wired and wireless, both options are there, and they come in very different various sizes which will allow you to use it according to your different purposes. Okay, so example is sometimes you use keyboards for gaming, you use keyboards for editing, you use keyboards for general purpose, so on and so forth. So each time a keyboard is used for a different purpose, that condition, you have a different type of a hardware to achieve that goal. Okay, so mouse, as you all know, a mouse is basically a pointing device and which will allow you to control the cursor on the screen, right? Simple as that. So when you're writing this down, you please write down the first set of points. So please write down the first point, which is in this case mice are pointing devices used to control the cursor on a computer screen. Okay, remember to write it down because these will be the points which will be there in the question paper. Okay, and then joysticks. So joysticks is again an input device, but here in this case this joystick is primarily being used for gaming, right? Gaming, or it can be used for another purpose which can be something similar to simulations. So example is, yes, we do game using the joystick, but then again there are flight simulations and different types of simulation tools where usage of a joystick will allow you to control that plane. Okay, so that will basically make sure that your system is intact and you can play it properly. And then microphones. So microphones are again, as we start during the beginning of the lecture, I explained, microphone is the device which will allow you to capture sound and convert that sound waves into electrical signals, and that will be saved, right? So the definition is microphones are input devices that convert sound into electrical signals. Okay, so write that down so that you know what the point is. Okay, so if you guys need more time, you can go through the video again and pause the video and you can note this down. And then we have scanners. So what is a scanner? A scanner is basically similar to a camera, right? So what it does is it basically scans the picture and it captures it into the computer by converting it into a digital file. Simple as that, right? So it captures everything and it knows to read the content on the image. So here you can see, in this video you can see, here this is the sensor, right? This is the sensor which is moving back and forth, and on top of that sensor you can see there's a light bar, right? So this light bar, what it does is, this will basically read whatever the content which is there on the paper, okay, and it will save it. Okay, so that will convert it into binary data, right? So that's how it basically works in saving the data. Then we have monitors. Monitors also almost simple. Guys, remember to write this down. So the scanners are input devices that captures images or documents and convert them into digital files. So that's the definition of a scanner. Then we have monitors. So definition is quite straightforward in this case, because monitors are output devices that display visual information from a computer, right? So not a TV, don't mix this up with a TV, because the TV's sole purpose is to show whatever the input which is being given into it. But in this case, in a monitor, the purpose is to use it as an output device which will display information which is being pushed out from a computer. Okay, so these monitors, they come in different various sizes, resolutions and panels. So we do have LCD, we do have LEDs, we have OLEDs and different types of panels as well, which has different levels of colors and color supports. Okay, and then anyway, whatever said and done, a monitor is something essential when it comes to the interaction with the computer, right? Without a monitor, you cannot see the output. So a monitor is an essential device when you are building up a PC. Then speakers. So speakers, as you guys know, it's simply an output device, and as the definition says, speakers are output devices that produce sound from electrical signals. So remember the words, speakers are output devices that produces sound from electrical signals. Okay, so why do we need speakers, and why do we use speakers? Primarily, they are used to listen to music and watching videos, and anyway, even while playing games, you need to have sounds, so you would be using a speaker. And a printer, in the other hand, the printer is something else, where you have the option of getting a printout, right? So using the printer, you can actually get a printout, and in this particular printout, you can have the computer print the details, like as you can see here, it's basically printing. You put the paper and the computer prints the paper and it gives the paper out, right? So that's how the printer works. So there are different types of printers. We have inkjet, laser, dot matrix, and depending on the technology, we do have a lot of different types of printers. Okay, so they all work in a specific way, where they all have their own specific processing, which will basically end up by giving us a printed output. Then video cameras, simple as it says, you guys all know what is a video camera is. So the video camera, the sole purpose is to capture the video and save it in a digital form, right? So how do you do that? So the idea behind this is, video cameras are input devices that captures moving images and sound, and they are used for recording video, streaming, and video conferences. So you can take this down, and this is the official definition for the video cameras. And then, same as video cameras, we have webcams. So webcams are small video cameras designed for use with the computers, and they typically build, so most of the webcams, they actually come inbuilt in laptops most of the time. So about 90% of the time you get the video camera inbuilt in the laptop, and the webcam is basically created for video conferences and live streaming, and mainly for live communication as well. So it depends on your use case, but it is again a similar device such as a video camera. What it does is it allows you to track and allows you to show your face, like capture your face, and send the details to the other recipient in the call. And touch screens. So touch screens, they are commonly found in almost everywhere, in smartphones, in tablets, in laptops and all. So touch screens are, okay, so read the definition and write the definition. Please do write it down. Touch screens are input devices that allow users to interact with a computer by touching the screen. Okay, remember the definition, I'll read it again. Touch screens are input-output devices that allows users to interact with a computer by touching the screen. Okay, what here nowadays you can actually see it almost everywhere because touch screens are very popular now, and at the same time you might see touch screens in multiple different locations as well. Nowadays we have this even the ATM machines, the teller machines which you take cash out of from, so they have also implemented touch screens, and you have a lot of different types of touch screens available. And then we have the thing called a graphic tablet. So a graphic tablet is a small tablet, as you guys can see here, see in the video. So this is a tablet where you will be using a pen. Okay, so using this pen you can actually draw on it. So you can see this guy he's basically drawing something, and you can see the output on the screen itself. So the graphic tablets, what's the definition? So the definition is graphic tablets are input devices for drawing, painting and video editing. So you use this device to specifically perform any one of these activities or all these activities, and since it's flat, it gives you an easy option to write stuff. Okay, you can write as much as you want, and since it's basically similar to a tab, the data is immediately transformed into data and it is being saved. Okay, so nowadays graphic tablets are very popular among artists and designers because they are easy to use, and because it's easy to use, for the creative person or for anyone who is good in drawing, they can draw whatever they want. It's not like okay, so if you take a canvas, if you're an artist, if you draw on a canvas, if you make a mistake, it's done, right? There is no way of let's say recovering back or going back to what you did before, right? So there is no way to do that. But in this case, yes, you can, because you can, just like that, you can easily revert back to the beginning and you can erase and start over, right? So that's the idea behind a graphic tablet. Then biometric devices. Biometric devices are the scanners which will take the input as one of your biometric entry points. So what will it be? It can be one of your unique characteristics. It can be your fingerprint, or it can be your voice, or it can be your retinal scans, right? So any one of these items or these parts in your unique parts in your body will be recognized using a biometric scanner, and this biometric scanner then will save that information and will use it to verify you. So example is, now most of the phones like iPhones now have face recognition. So all you need to do is just look at the iPhone and it has a scanner which will scan your structure of your face, including your eyes, and it will unlock. So without your face, technically you can't unlock. Like if you give your phone to another person, if they try to unlock, it will not work because it's locked to your face, right? So write down the topic, the point explanation. So biometric scanners are input devices that capture and analyze unique biological characteristics. So these three are the keywords: unique biological characteristics, such as fingerprints, iris patterns, or facial features. Okay, So all these items are specifically required, and they are used for identification, authentication, and of course mainly for security purposes, right? So as long as somebody can find your password or replace your, let's say, email address, they can do whatever they want, but they can't replace your fingers, and they can't just copy your fingers, right? unless unless you actually go there and give the acceptance or the approval. Nobody cannot actually copy your biometrics. That's the reason we use biometrics. Then we have barcode readers. So barcode readers is actually something common. Everybody know what this is. So barcode readers and QR codes, they work the same. So barcode readers are input devices that scan barcodes, which are a pattern of black and white lines that represents data. Okay, so you guys have seen this at multiple locations, like as in supermarkets and scanning locations. So remember to get down the topic. And on top of this, we have another point called chip and pin devices. So this chip and pin device this is what they call it actually. The actual word they used to call it. But ideally, a chip and pin device is basically a credit card, right? So these devices, they do have a chip and a pin associated with that particular chip. And when you put that into the card machine, it validates and it allows you to perform a transaction. So chip and pin devices are used for secure payment transactions. Okay, that is what they are being used for. Okay, and then sensors. So we have a lot of different types of sensors. So primarily, why do we need a sensor? A sensor is something which will use to capture a specific input from a location or from some sort of an action, right? So see here, you can see in the video that light glows up when it reaches a certain point. So it basically checks for the specific location of that conveyor belt or that particular thing which is running on top of the conveyor belt, and it analyzes it and it finds out the space, and it waits until it moves to the correct location and it pulls that device up and rotates it. Okay, so in order for this to happen, it requires a certain set of sensors to fire, right? First, one sensor has to fire when this approaches the location. Then another one checks the sensor and then it rotates it. Okay, see, there's another light and it moves out. Okay, so the sensors are actually being used to track and detect or measure physical things. It can be temperatures, it can be light, it can be motion, it can be pressure, or any other physical thing which we cannot detect without having a sensor, without having these items. So they are used in various applications, including environmental monitoring, industrial automation, and consumer electronics. Okay, so now with this new Internet of Things and with these new devices, sensors are being used everywhere. So sensors allows you to use lots and lots of different devices in different ways, and it allows you to give more features to users as well. Okay, mobile phones. I'm not going to go through this particular point because you know what is a mobile phone. But remember to write down the term. A mobile phone, also known as cell phones, are portable devices designed for voice communication and text messaging over cellular networks. I know this is not what you're thinking. This is not a smartphone. This is a mobile phone. Okay, so back in the day, we call them mobile phones. As I said, we had these car phones back in the day. These are known as mobile phones. But these phones didn't have any features in them. They were just designed to take or do one thing, that is to take calls. Okay, so they came in various shapes and sizes with different features, and ultimately they were transformed into smartphones. Okay, and then a smartphone is something different, where smartphones are pocket-sized computers with advanced capabilities, with which will allow you to go beyond the limitations of basic communication. Okay, this will basically allow you to go beyond the basic limitations, and they will give you a lot of different features. And okay, so give me 1 second. Yeah, okay. So we'll quickly go through this as well. So storage. So storage, as we discussed before, there are different types of storage, and we have the primary type of storage called magnetic storage, which you can see. This is how the average magnetic storage disk works. So you do have a disk which rotates close to 7,200 rounds per minute, and while this is being rotated, the data is being written by this particular arm while it's moving back and forth, and it changes the magnetic polarity, the magnetic polarity of that particular block. So when that changes, the number automatically changes from 0 to 1, which will allow you to store some data. So please write down the point where it says magnetic storage devices store data by magnetizing tiny particles on a rotating disk or tape. Okay, so hard disk drives are the most common example, because they are used in computers and servers for long-term storage. And then we have the solid state drives, SSDs, also in a short term, which is again same as hard drives, but the thing is they are not connected to, they do not have any physical moving parts. So SSDs have a different way of working, using transistors to store the data, and these are much faster. That's why nowadays the new machines are actually quite fast compared to what we had before, and the storage is also extremely fast. Please write down the definition. And then we have the magnetic tape drives, which is again a storage drive where it stores the data on a tape, and this will allow you to store large amounts of data. And you have removable solid state SSID cards as well. So these are the SD cards which we call them as. So SD cards, we all know, we put them inside phones and devices, which will allow you to save much more data than your device allows. So these are removable solid state cards like SD cards and micro SD cards. They are portable storage devices used in cameras and smartphones and other devices. Okay, and then we have the network attached storage, which is known as NAS. So network attached storage is basically a network storage system which will allow you to store your data into a network connected PC. Okay, so this will basically allow you to store whatever the data point into a PC which is connected to the network, and since it's connected to the network, you can access this PC from any other location within your network. So write down the definition. It's a NAS devices are detached file servers connected to a network, dedicated file servers connected to a network, providing centralized storage accessibility by multiple users. So basically it gives you the accessibility from multiple locations through the network by multiple users. Okay, so they offer features like data redundancy, backups, and remote access and whatnot. You get a suite of features, and plus they are very popular in small businesses and homes because they allow you to share data across different devices. And then you have RAID. So RAID is one move feature where basically you used to connect multiple devices together and you have the option to store it. We will be going inside this later on in one of the other lectures when we talk about storage. But for the moment, remember to write down the definition. The RAID, redundant array of independent disks. Disk storage combines multiple hard drives into a single logical unit to improve performance, reliability, or both. Okay, different RAID levels are offered when into varying different levels of data protection and speed. So RAID is commonly being used on servers. So that's the wrap up to this particular session. So what's next? So the next is we'll be talking about understanding the technologies. So we'll jump into understanding the technologies of what is hardware and software, and we'll talk about hardware components like processors, memory, and sensors, and all these small factors which is there which will help us run the system.